Afternoon, everyone. Can you all hear me? I can hear myself, so that's good. That's good. Right, so I'm going to talk about stadium Wi-Fi design. There will be a little bit of overlap with Connor's presentation, but that does mean you can seamlessly roam between the two. Great. Jokes work. Brilliant. So I did this presentation at WLPC in Prague. This version is a bit more cut down, a bit more slimmed down, and there's also an interactive element. So I'm going to ask you shortly to get your phones out, scan a QR code, and in the interest of sharing your knowledge, you can input your knowledge and share your knowledge with everyone else. So we're going to look at, for stadium Wi-Fi design, we're going to look at the design considerations, we're going to look at AP placement and capacity calculations. Now it's the design considerations that we're going to share information on. That's going to have the QR code. The AP placement, I'm going to do most of the hard work there myself. And then capacity, again, I'll present a solution and you can provide feedback to that at the end. Unfortunately, not much time to talk to me about myself, just that I also manage a kart racing team, so feel free to talk to me about that later on. So the site, this is Fulham Football Club. It's in South London, nice little location down by the river. We're focusing on the Riverside stand for this particular presentation. So there's lots of different RF environments here. So we've got the health club at the nearest end that we can see. There's studios, there's gyms, there is wet areas, so potentially spas, saunas, that kind of thing. There's also outdoor areas with the swimming pool. There's a bar at the top there. In the middle, there's a big open public concourse area. There's also lots of concessions, bars, restaurants, etc. Event spaces. Down the far end, there's a hotel, so small, low occupancy rooms. The most interesting bit, though, is the actual bowl itself, the seating area. So this is 11,800 seating capacity. As you can see, sort of down the end there is likely to be client usage of people videoing the actual game, and probably everyone's going to want to upload that footage after a goal or something exciting. I don't know what happens in football, really. Right, okay, the next slide should be the QR code. So if you could scan that, and then what I'm after is really the design considerations for this type of football stadium. So hopefully we'll get some results. My fingers are crossed that this is going to work. Yeah, I can see capacity is a really popular one. Yeah, definitely. I mean, we're going to come on to that one later. Cell size. Yeah, certainly. There's always comedians, right? Contention. There's going to be, yeah, potentially loads of overlap. Throughput is important. Cell size, we're going to certainly talk about AP placement and all that. So this is going to carry on running, so at the end, you can show what others have had. Someone loves Matt. Oh my gosh. Are you up there as well, Mac? Okay. So I'm going to move on. So AP placement. There's three options. There's up in the gantry, there's at the walls behind, and there's under seat. So this particular customer didn't want to go with the under seat. They didn't want to do the cabling there, and they were worried about trip hazards and that kind of thing. So the best option here was inside the gantry. It's quite big, so you can get easy access. You can service the APs. You can install them nice and easy, get cabling to them. So we've decided to put them on the gantry. So what about the beam width then? How do we calculate the beam width? So what would be the angle A? So I know Connor touched on some trigonometry. So does anyone actually remember from school what the formula is to find an angle? So obviously I've got the distance measurements just from the scale drawing. No one was listening that day, no? So it's cos A equals b squared c squared minus c squared all over 2bc, obviously, right? Remember now? Right, so it's quite easy just to put in the values, calculate down. We've got 0.2 there, but of course we need to get the inverse of that. So we'll work out about 80-degree beam width. So we understand that. Now, what angle do we need to mount at? So we could go back to the trigonometry. We could look at further calculations, but it's a lot easier to just put it into Ekahau, line it up, and then measure the angle. So what antenna to use? So the obvious antenna, it's in the name, it gives you a clue, is the Cisco Stadium antenna. It's even an 80-degree beam width, so absolutely perfect, right? But so we've got our 80 degrees this way, but we've got 25 degrees this way. So it's going to cover a lot of seats. Not ideal if we want to reduce our cell overlap. So the Acceltex one is 110 this way and 15 this way. So a lot more narrower. This one's actually designed, it's a warehouse antenna, so it's designed for warehouse aisles, so that works nicely. Rotated the other way, you get a nice slice of seats. This can be seen with the cell size, so the Acceltex one is a lot more narrower, so we're going to be able to get a lot more APs in there before we start seeing channel reuse. Capacity. So I managed to put in 32 APs, 48 radios because some are dual 5 gig. I've done this capacity just on 5 gigahertz. The throughput there, so you can use the MCS tables and put in all the 5, 6, 7 different metrics and work out your data rate, but again, if you use Ekahau, it just kind of does it for you, so that's what I've done here, and I've come up with that 220 megabits per second. So I sliced that up per client, so the number of seats, I've assumed 50% of people are going to be actually using their phone, a kind of worst case scenario. Divide that up, clients per radio, and then that gives me the data rate data throughput per client. So this is obviously not the full picture, so that's why we've got another Slido where you can provide what you think you should use for capacity calculations or what you think should be considered. Oh, is it not working? Oh, that is a shame. Random number generator. Do you know what? Random numbering generator is actually probably the most accurate. Brilliant. I'm going to leave that going. I think I'm kind of out of time, am I? But yeah, as that runs out, but just thanks very much for listening. Thanks very much for participating. And have a good rest of your day. Thank you.